Hey,
Hey.
uh, I tried to do the problem from the morning and I have like a whole bunch of if statements for like and or but anyway, it's
Oh,
fun.
the binary search tree one?
The second problem,
Oh,
the
okay.
one with the bus.
Yo, check this out. That was actually not the easiest problem. That was a sort of challenging problem. I'm gonna share my screen really quickly. Check this out. So these are the problems from the morning. The the medium,
17%.
yeah,
This,
17%. The second medium actually had a greater percent acceptance percentage than the second one. The hard one actually had a
wow.
greater, I know, right?
Mm.
Which is
Okay,
surprising.
okay. Yeah, I submitted it like 5 times before it accepted. I was like, oh, edge case,
Yeah,
another one. Yeah,
yeah. I like the way that UT did it, where he stored them all in the hash map, and then he only had to
yeah,
focus on one of the arrays. We kind of did it. We're doing it like brute force, as brute force as it gets,
yeah.
really. On our first iteration, I definitely had some optimizations in mind, but we ran out of time. The I'm surprised that we had a binary search tree for the first problem, though. That's what really, I never see a binary search tree problem for the first one. I'll show you guys what that one looked like. I actually was just looking at it.
Huh.
This one right here. This was the
So there were
easy part.
problems in the morning too?
Yeah, bi-weekly they have a competition in the morning too. So 10 a.m. Eastern
Oh.
Standard Time to about noon Eastern Standard Time.
Oh, okay.
Yeah, that's a bi-weekly one. And I think that's a little more challenging than the nightly one from my experience.
Mm.
But yeah, this was the binary search tree one. We are just given a binary search tree. We had leaf nodes and non-leaf nodes. So the leaf nodes only consisted of zeros and ones, and those were trues and falses. And then the non-leaf nodes were or and or was represented with a 2 and was represented by a 3. And it seems kind of challenging when you first take a look at it, but let me
Hmm.
I'll show you the solution
So
on.
they give you the data structure and you have to evaluate it. You don't have to
Yeah,
implement the entire data structure, right?
yeah, they give you the data structure.
Oh, okay, okay.
So we had what's July 9th, then yeah, so at first I was looking at it, I was like, oh, what? I don't really get this. And then it's literally like this is it right here.
Yeah, that makes sense.
Took a few minutes. I think it was like 5 or
Hmm.
10 minutes for this one. And the second one we got caught up on this logic right here, but everything else was good. All the rest of our logic was good. We were gonna optimize there. Then we had this is some Python code. The UT worked on this solution right here, and same problem, just different solution. I think we spend 90% of our time just writing out the comments.
Do they grade the comments?
No, no,
Oh, okay.
nope. Yeah, so let's see if I go into the contest right here.
Forgive all my ignorance. I have no idea.
No, it's all good. It's all good.
Okay.
The more questions, the better, for sure. The better we
Hmm.
understand it, the better.
Hmm.
So this one
So I
is gonna
assume I have
start.
to register for it if I want to do it individually.
Yes. Yeah.
Okay.
Yep. So this one starts in about 20 minutes. Typically, we have two different groups. One of them is just working on a team. I stick with the JavaScript team. And then we have developers who just want to work independently, deafen their headphones, mute their mics, and just challenge themselves, do things solo. and that's totally fine too. So either or, if you have some experience coding, if you're a professional developer, or you've done data structure algorithm problems before, I definitely recommend challenging yourself. I feel like it's a lot easier when you're working as a team because you have that collective knowledge. So I'm
Mm-hmm.
just going to go ahead and make a directory called July 9 nights, and
What languages do they support with this?
basically any language you would ever want to
Really?
use. Yeah.
Well, 6 or 7, let's say.
No, way more than
I,
6 or 7.
like that. That's just asking for for me to try to pull out all these esoteric ones.
Yeah, see, this is the list right here. So we got,
Okay.
and
Oh,
then,
it scrolls. There are quite a few
Oh,
in
they
there.
do have
Okay.
Rust on there.
yep,
Yeah. There are a
Huh.
lot of languages out there.
nah, right?
Yeah.
I did want to start testing myself and do them in C, but I don't know if I'm ready for
Ooh,
that
that does sound fun. Maybe I'll try that some other time though.
yet. Yeah, soon, one day. Cool.
Uh,
So yeah, we have. So let me go to the contest right here. You can see the weekly contest 301. If I click on it, it's gonna bring me in here. You can see there's some prizes if you come in one of the top places. It's really challenging to come in one of the top places. There's some really good people here. The rule that I always point out, though, is that there's a penalty time of 5 minutes will be applied for each wrong submission. So if you submit a solution and it's incorrect, they'll tack 5 minutes onto it. And the reason why I point this rule out is because some of the top people in this competition, they're busting all 4 problems out in like 25, 30 minutes. So they're quick. 5 minutes makes a
oh.
bit, yeah, they're fast.
So that's how you get a higher score even if you pass all the tests then.
Yeah,
Oh,
you do
okay.
it quicker. So if you scroll all the way to the bottom, you'll see register now. A form will pop up. I always skip the form. I'm not interested. Continue to register and then register.
You don't even need to fill in the form. Okay.
Nah. I did the first time, but then I was like, wait a second.
Wait.
And then once the contest starts, the problem list will populate right here. So we'll have 1 easy, 2 mediums, and 1 hard. And yeah, that's it.
How long is it?
It's an hour and a half.
Oh, okay.
Yep, you
Perfect.
have 90 minutes to complete all 4.
Okay.
Yep,
Well, I'm registered now.
cool.
Huzzah.
Let me open up my Visual Studio Code editor for those who want to work with me. I'm just going to create this live share link quickly. All right. And I will post that in the lobby chat. There you go. So if you want to pop into my code editor, this live share tool is just like Google Docs. So if I make edits in the Visual Studio Code, you'll see them happening in real time. And then if you're making edits, I see them happening in real time. So it's a really great collaboration tool. And yes, after the contest, we talk about our results. So usually we start with the easy problem. We have 1 or 2 people share their solutions on that. Definitely where we encourage people to share more than one solution if they have different solutions. But if we both use the same algorithm to solve it, then, I mean, you can still share it if you want to, but we like to see different solutions. It's really cool. And then different languages is as well. That's one of the best things about these events right here is that, I mostly code in JavaScript, but when I see a solution in Python or Java, it's like I never planned on learning these languages, but I'm starting to learn methods and syntax in these languages that I never thought I would learn. And I think that's just really cool. It's not like I'm trying to learn or code in them, but I'm beginning to be able to read them, which is kind of cool, I think.
Mm-hmm.
Yeah, so
Yeah,
usually,
I'm probably better reading code than writing it, truthfully, after all these years.
mm,
I mean, give
well,
me some time and I'll write it, but I can read even brand new languages I've never seen, read pretty easy.
Yeah, yeah,
To
There's
be
just
honest,
so many similarities and patterns.
yeah.
honestly, that's a pretty valuable skill in and of itself.
Reading code.
Yeah,
Yeah,
there's a lot of really big code bases out there. Being able to pick that up pretty quickly is very, very helpful.
true, true. Let's see. Do we have anyone else new here? We have Older Get Wiser. You're typing in the chat, so I'm guessing your microphone's not working. And Krista, are you new, Krista? Have you been here before?
I'm new. Hi, how are you?
Pretty good. How you doing?
Good.
Awesome. Well, welcome, welcome. Looks like we got Dennis and Goat Dev. What's your name again, bro?
John.
John. All right. Let me not forget. John. All right, cool. Welcome, welcome. I just went over the rules, so we're just hanging out until it starts. We have about 14 minutes. Older Get Wiser says he's not feeling well. I'll save you from the sound of that. I said he. I don't know if you're a he or a she because I can't hear you, but what's your name? You can type it if you want.
My name is Mickey.
Oh, cool, cool. What's up? Welcome. Awesome. Yeah, this morning was a great challenge. It really was. We probably spent about a little over an hour trying to get that second solution out, and it was challenging. The acceptance rate, like you saw, was 17%, so not many people got accepted. But honestly, I'm just so surprised that they gave us a binary search tree problem for the first one. Usually it's a simple string or an array problem, so I was definitely caught off guard with the BST.
About
I had a side job this morning, so I wasn't able to do the morning one. So it started out with a binary tree, is what you're saying, and wasn't like the second one or third one.
No, it was pretty simple though.
All right.
It wasn't too
I
bad.
haven't even looked at it.
Yeah, I'll pull it up real quick. We have
about how many people like run in these contests generally?
thousands, probably like
Oh.
probably like 20,000 or something at least.
So if you manage to get like above 200th, then you're doing pretty good.
Oh yeah. We've had
Okay.
people come in here who completed all 4 problems and still didn't come in the top 200. Yeah. At that
Well,
point, it really comes
makes it
down to
more fun.
time.
Yeah.
Right, there's like guys that do this stuff in like 15 minutes.
I know.
Yeah.
If not faster sometimes,
Yeah.
Yeah,
I know.
our culture does in my opinion, a disservice how they focus on the very best of the best of the best. And there's something called the Pareto Curve, and it's just not everybody can be there. That's just the sad truth of life.
Yeah.
Yeah.
What curve, Kev?
Pareto Curve. It talks about how less than 10% of people do more than 90% of the work
Oh
in
yeah,
any
yeah.
class of endeavor.
Yeah, that's how it is in my business too. 20% of the reps generate 80% of the business.
Yeah, and that goes all throughout any kind of attempt at doing anything.
Yeah.
But Western / modern culture, we're looking at literally the 0.001%.
Yeah. Yeah, I know. Yeah, it's
It is
fun
kind
just
of
to
a
compete,
yeah. It's kind of
Oh
a
yeah, I'm not
stereotype.
saying nobody should compete. I'm not saying that. It's just
Yeah.
we pay too much emphasis on that, given that the corollary of that is 999.99% of people will never get that, never be that.
do you think that if you watch people who perform at a high level that you'll grow and become a better coder than if you don't?
Well, yeah, I mean, the higher you shoot, the higher you'll get, obviously.
Yeah.
I think people
But
focus a
you,
little
you
bit too
don't have to
much
be
on
at that level to be a hero.
No, absolutely not. Or even to be
I mean,
productive and be successful, you know?
to be
back
completely
when I
honest.
worked at the foster care company, well, we made software for the foster care industry. I kept a guy out of prison because our records were able to show that this young lady was falsely accusing people in agency after agency of inappropriate behavior.
Wow.
And we actually, some people were being proactive about it, and they even kept it out of the press. That guy's life could have been ruined even if he didn't go to
Yeah.
jail.
Yeah, definitely.
Ooh.
That's actually amazing. Wow.
Yeah, that made me feel pretty good.
Yeah. Pretty awesome.
What were the other problems this morning?
Let's see.
Like, so the first one was just you have a binary tree and you have to evaluate it as a Boolean expression. What was the second one?
This was the second one here.
Uh, okay.
Yeah, this one was fun.
Yeah, that one looks kind of involved.
Mm-hmm.
Mm-hmm.
Yeah.
Gives me some knapsack problem vibes.
Somewhat.
Knapsack problem.
How would you have solved it?
I don't know. I'd have to think about it for a bit.
Uh, what do you mean by knapsack?
Oh, the knapsack problem?
Yeah.
It's a problem in theoretical computer science dealing with optimizing let's see, optimizing the value out of choosing different items that will have a certain amount of cost. It is an NP complete problem. So there's no known like polynomial time algorithm for it.
Gotcha.
Mm-hmm.
An NP complete means it's solvable, or what exactly is it?
Oh, that's a can of worms. NP complete.
I've heard it
Um,
before. I've dabbled a little bit, but I'm like, what exactly does this mean?
so okay. So P means polynomial time. So there's some way to solve it where the runtime is polynomial in the size of the input. NP means that you can verify the solution in polynomial time. It is, but but it's not known if every single NP problem can be solved in polynomial time. However, if something is NP complete, it means that if you were to find an algorithm for it that could solve it in polynomial time, you could use that algorithm to solve every single NP problem in polynomial time.
And
It's
polynomial time is
um basically like you have an algorithm on something like an array,
yeah.
right? It has a size like n. The amount of time it'll take if it's polynomial time will be like you plug that size into the polynomial and that'll tell you like how long it takes to run.
Okay.
Mm-hmm.
Gotcha. I'm sure there's even more worms in that can that you're just holding back,
Oh,
right?
oh yeah, there are there are some can of worms.
Yeah, that's interesting stuff though.
Mm-hmm. I love it. I love how there's a countdown on the page.
Yeah, I know, right?
Mm-hmm.
5 minutes, 13 seconds. Should we scream Happy New Year's when it counts down?
Yeah, maybe the fireworks go off nearby. I haven't heard any after the 4th, but I did hear quite a few in the days leading up to it, for sure.
Yeah, same,
Oh yeah.
same. I heard some tonight. I'm definitely gonna hear some tomorrow night.
Hmm.
There's always fireworks. The week
Hmm.
before, the week of, and the week after New Year's
Oh yeah.
around here. Yeah.
Mm. And they're not even supposed to have those. Like they're not like legal in Illinois, I don't think. But they just go across state lines to just get all
Oh, you're in Illinois.
of them.
It's not legal to
uh,
have fireworks out there?
well, you can have like smoke bombs and sparklers.
Yeah.
That's and
Yeah,
like the little
because
pop-out
sparklers never
things.
catch anything on fire.
What? No, never.
The
Never.
little stuff that no one really wants anyways. They're like, you could have
Hmm.
the stuff no one wants.
Yeah.
But for the
It's
big
still
stuff.
it's still fun to be able to like throw little tiny things at the ground and have them explode. So
True, true.
it's still very fun.
When I was in,
Um,
I think like 8th grade, I was into model rocketry, and so I had a handful of spent engine casings. And they still had the nozzles are made out of ceramic, low grade ceramic, more like
mhm.
fired clay. So the nozzles are still good. And I'm like, that reminds me of a smoke bomb. So I tried to make them into smoke bombs, but it turns out they really, really wanted to be rocket engines.
Man, the guy who owns the yoga studio that I go to, he doesn't really run any of the classes. His wife runs all of the classes. He's just like the business side. He's an aerospace engineer, and we were talking about like building little mini rockets and that sort of thing. And he was saying there's clubs around here where all these engineers who, not even all of them are engineers, some of them are just hobbyists who like build their own rockets. They're not like massive, but some of them are like 5 feet tall or 6 feet tall, and they go,
That's
like,
that's respectable.
yeah, and that stuff sounds
You
cool,
pay
man.
you pay a few $1,000s to get a license, and you can make your own fuel.
Yeah, one of the guys who comes to our in-person meetup, he has his license from some agency like the FAA or something like that, where he could actually build something that goes above 400 feet. That's really cool stuff, man.
That's sick.
Yeah, that's really cool. Like he could.
That's sick.
That must be federal though, because I
Yeah,
think,
it's all
Oh
federal
yeah,
level.
yeah. FAA is federal.
yeah, he was saying like
Hence the F.
But
yeah,
there's one kind of license to make the fuel, and there's another kind of license for getting the clearance to launch stuff real high.
yeah, yeah. Sounds like there's a bunch of red tape and something like that
There
there.
is, but it's not insurmountable, but it's not for poor folks either.
Yeah, it'd be fun. It'd be fun. It'd be a nice like something to do with my son. Like he's in robotics club, so not that we'd be able to figure anything out in like even a month or two, but just like a long-term hobby. Join one of those clubs and
I've
just
seen some
learn.
YouTube videos of guys trying to land solid fuel rockets like SpaceX.
That would be so cool, man. Cause there's got to be a way you could
Well,
slap like a Raspberry Pi or some type of
there's
computer
no
on
real way to
there.
throttle it,
I
so it hasn't. I haven't seen anybody come close to succeeding, but it's fun to watch them try.
Yeah,
well, I
yeah,
mean, if you make the rocket small enough with liquid fuel, I imagine you could have something. If it doesn't go too high, it's small enough and everything.
yeah, yeah,
Yeah, and that's the thing. Without a proper license, liquid fuel rockets are a no-no, and
Oh,
people
oh,
take a
I
dim
see.
view of them.
Wonder if you could like redirect the thrust somehow to like
That's what they try to
take
do.
trouble.
They try to spray the thrust out sideways instead of down,
Hmm.
but it has to be very carefully balanced, and that's where the real trick of it lies.
Right. And you don't
And
want
then
it
you
to
have to
like
have all that
spin.
brain in a very lightweight package.
yeah, yeah.
Hmm.
Yeah, that would
Yeah,
be
it's
a
not
fun
trivial.
challenge. Yeah, that would be a fun challenge. Not like a
I
three
mean,
month project, but like a long term, like 1, 2, 3 year thing. My son's 15, so
uh,
it like just seems like a fun thing.
mhm. Well, we've got like 15 seconds
Uh-oh.
for the thing. Yep, yep.
Cool.
Hmm.
I'm always so nonchalant and chill with these competitions.
Yeah, I
It is.
normally am not, but I really should be. It's like perhaps it will be this time around.
Happy New Year.
And they're off.
All
Let's
right,
see
let's
if I can
see.
even find out how to open this.
Let's see what we got here.
How do I open it?
All right, let me just get the code editor set up quickly here. Oh, looks like we got a couple people joining.
How do you actually like see the questions?
What page are you on?
I'm on the weekly contest 301 page.
If you scroll all the way to the bottom, they should be down there.
Oh, I see. Lol. Okay.
All right. Fill cups. Looks like we're just passing an array in there. Good luck, everybody.
Oh,
All right. Let's see what we got here. You have a water dispenser that can dispense cold, warm, and hot water. Every second, you can either fill up 2 cups with different types of water or 1 cup of any type of water. You are given a 0-indexed integer array amount of length 3, where amount 0, amount 1, and amount 2 denote the number of cold, warm, and hot water cups you need to fill respectively. Okay. Return the minimum number of seconds needed to fill up all the cups. Okay. So one way to fill up the cups here. So this would be how many cold cups need to be filled up. This would be how many warm cups need to be filled up. And this would be how many hot cups need to be filled up, right? Am I reading this correctly?
cold, warm, hot. Yeah.
And then you could fill up 2 cups with different types of water or 1 cup of any type of water. So in this case, you would fill up one cup of the cold water at the same time you're filling up 1 cup of the warm water. So this would be 0, this would be 3, then you would have 3 and 2, and you'd be able to fill up the hot and the warm at the same time, 2 at the same time. That would leave you with 0, 1, 0,
Mm,
and so 4. So 4 seconds. Am I reading this right? One way to fill up the cups is second 1, fill up a cold cup and a warm cup. Second 2, fill up a warm cup and a hot cup. Second 3, fill up a warm cup and a hot cup. Second 4, fill up a warm cup. Okay. It can be proven that 4 is the minimum number of seconds needed. And then with this one, you can only do 2 at a time, so it'd be like 4.
in a strange way, this is a path problem. Kind of a find the shortest path type thing.
Hmm. Cold cup and a hot cup. Cold cup, warm cup. Oh, okay. So it looks like at least what this is inferring is that if there's if there's three elements that still have values, you want to decrease the two highest. So it'll just be 5. Length is always going to be 3. We're always just going to have a cold, a warm, and a hot. And then the amount I is going to be in between. So each one of these is going to be in between 0 and 100. All right. What do you mean by path problem, Kev?
Well, there's a pattern to the filling on any you using any algorithm or any combination, and so that whole set is like a bunch of paths, and you're looking for the shortest one.
I don't really get it.
Well, the simple rule I see is that you always try to always work on the odd man out, basically.
What do you mean?
Um,
I know you got a
I
good
don't know.
idea too, man. I know you do. Don't even hide it. You're a
Well,
metaphor guy, bro. You say things in metaphors, but I know you got something good there. You always do.
I don't know. It seems like it'd be better to anytime you can fill 2 cups, that's better than filling 1.
Definitely. Yeah.
But it doesn't really matter though. Like on that first example, they fill up a single cup on the very last step. Although by that time the array is, there's no option really.
Yeah. The maximum amount of cups you can fill up
You
for
can
each
fill 2 cups if they're different, 1 cup if it's of a single. If they say any, that's just trying to confuse you.
Yeah, yeah.
This is tricky.
Yeah, I'm just thinking of the best way because I could think of a way to do this if we just scan the array a bunch of times, but that's super inefficient.
How about some kind of, I don't know how to say this right, decrementing or decrementing counter that, like you said, you scan the array, you put into a variable like the highest number, and then you have some kind of a counter that will count the amount of times each second is decremented.
Yeah, so you're saying just figure out what the max in the array is and decrement that, right?
You know what? Not even decrement, because it's going to have to be at the very least the highest number in the array.
Yeah.
So yeah, I shouldn't be subtracting anything. Huh.
And then you would also have to find the second max too.
Yeah, I guess so. Because of example number 2, that's what it illustrates.
Even example number 1. With this, yeah, I guess with this one you would decrement 5, 5, and 4. So you'd have 4 and 3. Then it would be 4 and 4. So you have 3, 3, and 3. Then it doesn't really matter. 3 and 3, 4 and 3. So you'd always want to do the highest one, right? To make sure that you're decrementing. Well, you're using the minimum number of seconds needed to fill each cup.
Yes.
So you'd have to always be focusing on that maximum. You'd have to be decrementing the maximum. And I say decrement, but there's probably a few different ways we could do this.
Yeah, that sounds about right.
The thing is, though, with that method, are you talking about scanning the array with each decrement? Because we could do that, but then that's going to be like, or
Traversing the array for nothing
it's just going
too
to
many times.
be, yeah, it's going to be looping through the array, like looping through this array, whatever the output is, number of times. So it's going to be n times whatever we're outputting, which seems
Okay.
super inefficient. I feel like there's something better here. I feel like we're just not
Yeah.
seeing something here.
The time complexity would be bad.
Yeah, especially if one of these was 100. Which actually isn't too bad at the end of the day, because the maximum each one could be is 100, and we know we're only going to have 3 indexes. So if you think about that, the most number of calculations we're going to have to do for this problem is 300 calculations. Not even. It's going to be way less than that. It's going to be, the max we're going to do is 100, because the max any one of these is going to be is 100. And when you're talking about CPU and runtime, like 100, if we know our max is going to be 100 operations, scanning through it like that is really,
But the sneaky part is an algorithm that always gets the minimum number of seconds.
exactly.
You can make an
Exactly.
algorithm that always fills them, but it has to be in the minimum seconds.
Yes. So let's say at the maximum, each one of these are filled to 100. So this one would be, it'd go from 100 to 99, 100 to 99. So we'd have 100, 99, 99. Still, at the end of the day, if we know that the max each one could be is 100 and the maximum number of indexes in the array is 3, at the end of the day, if this 100 right here was like a million, and we knew that there was like 100 different temperatures of water, then sure, that algorithm's not going to scale. But since we know that these numbers are so small, that then scanning through the array a bunch of times is not going to be as efficient. It's super brute force. There's definitely a better way to do it, but it'll work. Or we could just give it a couple more minutes and just really, really think about it and find something a little bit more efficient. Down for either or. Let's try to think about this different. I wonder if there's just a formula we could do. Because if we scan through this array and we know 1 is 5, 1 is 0, and 1 is 0, since we know that 2 are 0, we know that it's going to be 5, right? And with this one, if 1 is 5, 1 is 4, and 1 is 4, there's got to be some type of formula that we can just execute so we don't have to scan through this a bunch of times. Because, yeah. So if we have 5, 4, and 4, that's 9, 13, right? So we're able to subtract 2 each time from 13, right? So if we subtract 2 from 13 6 times, and then we have 1 left, and that's 7. So we could tally these up and divide by 2, and then if we have anything left, add 1. If we don't, then that's our number. Hello?
Go through that one more time slower.
Yeah.
Yeah, so look, if we have, let's just say we have 5, 4, and 4, right? So we could just add those up. 5 plus 4 plus 4 equals 13. 13 divided by 2 equals 6. And then,
Well, 6.5.
well, let's just say, yeah, 13 modulus 2 equals 1. So we know we have 1 left. But, yeah, 13
No, I think you were right the first time.
divided by
13,
2
yeah.
equals 6.5.
So we're paying attention to the 6, and then since there's a remainder, we add 1.
Yeah, if
All
there's a
right, you round
remainder,
it
we
up.
add 1. Yeah, 6.5. So we would do 6. And since there's that 0.5, then we do 6 plus 1 equals 7. So we get that 7. And then if it's
Sure would
5,
like to see more cases, but
the thing is if it's 5, we're not going to be doing any dividing by 2. So that's where it gets a little tricky with this. Cuz if there's multiple if there's cold, medium, and hot, then we could do the divide by 2. But if it's just 5, we can't do 5 divided by 2. We have to do 5 divided by 1, which would give us 5. Because we could, if it's only 1 temperature of water, then we could only divide it by. Yeah. Okay. Okay. I think I know what we
so
could do.
divide by the number of non-zero,
Yeah. Yeah.
because we
Okay.
need to look at a case where there's 1 0, like 1280 or something like that.
Hmm. Yeah. I think we're onto something here.
Yeah, I think you are.
Yeah. Because if we go through here, right, and we do 4 plus 2 plus 1, we have 6. 6 divided by 2 would be 3, but that actually wouldn't work here. So we could take the greatest number, and if the two other numbers added up are less than the greatest number, we know that the number being outputted is going to be the greatest number, right? Yeah, so there's a few different cases here. But it'll definitely be easier than scanning through the array. Or it'll be more efficient than scanning through the array just over and over. Because we could easily just scan through the array with like a remaining cups equals 2 or something like that. Let's give it a little thought.
There is no way this is an easy problem.
It's tricky. I feel like there's something we're overlooking. Let me see. Mount 0, Mount. Alright, so let's just try to see this differently. So 142,544,000. So if we know if one is greater than 0 and the other two are equal to 0, then it's always going to be this digit that's greater than 0. It's always going to be 5. But if 1 is greater than 0 and the other two that aren't the max are greater than the max combined, then it's going to be the max five. This is 8, right? Like this is 8 right here. So together it's 3 more than the max. Yeah, trying to think, because look, if we have 1, we have our max, and the other two are both 0, we know that the number of seconds is always going to be the max. If we have a max and the other two digits combined are less than the max, then we also know that the answer is going to be the max. But if we have a max and the other two combined is greater than the max, right here we have our max, but 2 plus 1 equals 3. So we know that it's going to output 4. We know that the seconds, or the minimum seconds required, is going to be 4. But if this was 2 and this was 3, and the other two that weren't the max were greater than 4, then we know it's going to be greater than the max. So we have 3 situations here. We have one where we have a max value and the other two are 0. In that case, we just return the max. We have another case where we have a max and the other two digits are not 0, but they're also less than the max. And in that case, we just return the max as well. And then we have the case where we have a max, we have the other two that aren't the max, or they might even be equal to the max. And I'm just trying to think of like how we would calculate what we would return on this, because this would be the only one that we actually have to. These are 2 edge cases that are easy that we could just return the max, right? Let me go ahead and just type those out and see if we get the right answer for at least the first and the last one. So let's just say, to make things easy, we have cold equals amount 0. We have warm equals amount 1. And we have hot equals amount 2, right? So if actually,
Probably better off looking at it as an array because you can get your max real easy.
I was just gonna pull out the max, because we do need the max, right? Yeah.
You can do an array dot sort A minus B, return A minus B.
You're
The second
saying just sort the amount array, because
Yes,
then you know that whatever you pop off the end is gonna be your max.
right.
You're not going to know whether that's the cold, the warm, or the hot, though, right? You're saying that doesn't matter? Yeah, you're right. That doesn't matter.
No.
So we could do an amount dot sort A, B. Make it easier to read. Okay. That. Cool. All right, so now that's sorted. We have our max. Let max equals amount dot pop. So now we have, now we know, now we could do if max is greater than amount 0 plus amount 1, which are the only things we have, then we could just return max. Also, if amount 0 equals 0 and amount 1 equals
The
0.
first condition covers that, right? The second condition.
Max. True. Yeah. True. All right. So the only one we have to cover is this last one. Then let's test this out and make sure. So these ones should return as 5 and 4. Yep, 4 and 5. Yeah. So we just need a case to handle this middle one now.
Second one should put out 7.
Yes.
You come up with the formula.
Yeah, we just need a formula for it, right?
You explained it earlier, right? And then how did you come up with that divided by 2 and then add the
Well, yeah,
remaining?
the modulus, right?
Oh yeah, so you're saying the total of all of these?
Yeah.
All right, so in this case, we're just adding the max to amounts and amount 0 and amount 1, right? So we could say let, and I'm just not even giving it too much thought, but equals max plus amount 0 plus amount 1. And then we just do, let's see, so we got 13. And in that case, we would do total. Is it modulus or just divided by 2? Because if we do total divided by 2, we'll get back 6.5. If it's 6.5, if there's a remainder, we could round up. But all right, so would something like this work? If we just do math dot seal. Because if total is 12 and we do 12 divided by 2, we'll get 6. And if we run math.seal on 6, we're already at an even number, so it'll stay at 6, right? But if it's 13 and we divide it by 2, then we'll get 6.5 and it'll round up to 7. Let's check. Yeah, so we got 7 on this case. And then we'll just return total. Okay, so 475. The thing I'm curious about is like, what if this covers these 3 cases, but what if
Right.
this one was like 50 and then we had 4 and 4? Well, in that case, it would just be 50.
We'll get an answer, but how do we know if that's the minimum?
In that case, it would just be 50 though, because if that would cover this case here. Yeah, let's
In the
try it.
first example, they say it can be proven that 4 is the minimum number. I'd like to see that proof.
This is the proof, the output. Just playing. Let's test it out. Let's see if it works. I don't know.
Yeah,
There might be some edge cases, but let's
I
see.
don't have any money on this.
So 4 accepted. Hey, I'll take it. Cool. Good job, everyone.
Yeah, good job.
That's a weird kind of quinky dink that you can just divide by 2 and round up.
Yeah, yeah,
But that's in the nature of the way they stated the problem.
yeah. This is much better
Somebody with
than if we
a
stayed in
math
code.
master could probably tell us why.
Yeah, exactly, exactly. Okay. Yeah, that looks good. All right, let's check out the second one. Cool. Smallest number in infinite set. Um, go. Oh yeah, this one looks like it's gonna be fun. Cool. So we're gonna have an input. It's gonna be an array. All right. So you have a set which contains all positive integers. Implement the smallest infinite set class. Smallest infinite set initializes the smallest infinite set object to contain all positive integers. Integer pop smallest removes and returns the smallest integer contained in the infinite set. Void add back adds a positive integer num back into the infinite set if it's not already in the infinite set. Okay, let's try to wrap our heads around this one.
That word infinite makes my hair stand up.
Yeah, that's what kind of got me. All right, so if the input says smallest infinite set, that means we're initializing an infinite set, right? And this is being passed in with it, right? So there's going to be 2 arrays passed
All
in.
positive integers. You can't put that in a computer memory.
You have a set which contains all positive integers. Yeah, the output here definitely doesn't have all positive integers. It has 6 integers. 2 of them are the same. All right. So if they pass in an array with a bunch of commands, and then another array.
Oh, they're just saying that everything they pass you is a positive integer.
Okay. So it's not going to be negative.
Or nothing, apparently.
Okay.
So you'll get a null or a positive integer. Okay. My hair can lay down again.
So the first command is a string smallest infinite set. That's going to initialize the smallest infinite set, right? And I think this is really just going to be a return new set at the end of the day, right? Like a new set. And then smallest infinite set, add back 2. 2 is already in the set, so no change is made. Okay. So they pass us in an initial set, basically. Smallest infinite set, pop smallest. Return 1 since 1 is the smallest, and remove it from the set. Okay. So we would remove that 1. Pop smallest, return 2, and remove it from the set. So we pop that 2. Pop smallest, return 3. Well, I don't see a 3 here, though. That's the thing. From the set. Add back 1. 1 is added back to the set. Pop smallest, return 1. Yeah. So we know num is going to be anywhere from 1 to 1,000. And then at most 1,000 calls will be made in total to the pop smallest and the pop back. What is this? What is this thing right here?
Scroll that thing to the right, because yeah, it's not making any sense to me either.
Let me copy and paste it
Okay,
into the
we
code.
get an array of words.
It's bigger too. There we go.
We get an array of words, and then we get an array of arrays.
Okay. So there's only numbers in the add back commands. So we have 2 and we have 1, but only where it says add back.
Oh, wow. Why don't they just say, like,
Because add back
add back
requires
equals
an
2 or
argument.
something?
Yeah,
Yeah,
okay.
that's messed up.
I get that. Okay, because smallest infinite set, the initialization, and all of the pop smallest commands, they don't require arguments. But the add back does require arguments, and they're showing you what the argument is going to be. Oh, okay. Okay, that makes sense. So each time you run the command, if it has an argument, then use that argument for the command, and otherwise, just run it. Okay, I get it.
This is a weird problem.
Yeah, if this is a medium and the last one was easy.
Well, I mean, this is a simple algorithm. It's understanding the problem that's weird.
Yeah. So new smallest infinite set is gonna initialize the infinite set. You have a set which contains all positive It's yours.
At most 1,000 calls we made in total to pop smallest and add back. That seems to imply to me that our smallest infinite set is something like 1 through 1,000.
Yes. Yeah, because number is only, it's going to be greater than or equal to 1 up to 1,000, and at most 1,000 calls will be made.
That will fit in a computer memory.
Yeah, definitely. Smallest infinite set.
So now they just have to implement the methods.
How would we initialize this set?
Well, I assume you create create a set and then just start pushing, make a loop and start pushing integers into it. 1, 2, 3, 4, 5, 6, so on. Here's where I fall down because I'm not really used to JavaScript sets.
Yeah. Set infinite set equals new set. Do for let I equals 0 while I is less than 1,000.
I would be 1. We don't want 0.
Yeah.
Positive integers only.
I plus plus. Infinite set dot
And I don't know if you dot. Okay, it's dot add. Okay.
I.
And it doesn't. Well, here's the trick. It's a class. Your smallest infinite set is a class.
Yeah.
And all this does is initialize that variable.
So like this.
So you don't have to really return it. It's a class member,
So it'll just be in there.
but you have to write a class, dude.
Yeah, I'm thinking because this is the old school way of writing a class, right? A function constructor for the class. Like this is the actual constructor here, and then you're adding the methods on into the class with these functions here. Huh.
But I'm thinking that puts infinite set. Oh God, JavaScript is ugly to my eyes.
Yeah.
What is the this when you say this?
Just referring to the infinite set object.
But I don't see where that object is declared anywhere.
It's not. It's declared when they call it, right?
Hmm.
Hold on, let me think.
Right. We need to be able to create an object and then loop through the input, telling that object, calling the object methods.
Yeah, and we're not going to be passing anything into this. We're just going to, upon initialization of the smallest infinite set, yeah, so when they run new smallest infinite set, that'll create smallest infinite set.
I'm just really used to seeing the keyword class in a class definition.
Yeah. Yeah, that's a newer way. I mean, not really newer. It's been like that for a while. They just have it structured with the old way of doing it.
Well, let's just bang out the methods and then we'll worry about how to sew it all together.
Okay, I'm just thinking about how we're gonna actually access these arguments here too. It's a little confusing because they pass
Well, that'll
in.
be another loop. We'll take the first of each array, and that becomes an operation basically. So smallest infinite set, it tells it to initialize. It doesn't get a parameter. Add back gets parameter 2. Pop smallest gets a null parameter. Pop smallest gets a null parameter. Pop smallest gets a null parameter. Add back gets the 1. So it doesn't look like it, but there's a correspondence there. It's the same index into 2 different arrays.
Yeah, so if we are popping the smallest,
Somehow we have to ask the infinite set, what's your smallest member?
yeah. If it's sorted though, then we'd really just be shifting the smallest off the front, right?
I find that assumption uncertain.
Yeah, let me see. So add back 2 is already in the set. So we can say add back, they're passing in a number. So if this dot infinite set has num, then what are we returning? Add back adds a positive integer num back into the infinite set if it is not already in the set.
I don't think you're returning anything. I think that we can just we have to do something if it's not in the set.
Yeah. So if this dot does not, then if it's sorted, we'd just be unshifting it onto the front of the set. Actually, we don't have to do it on the front or the back, right? It doesn't say it has to be ordered.
Right.
So we could just push it on.
Well, looking in the docs, the add method appends a new element. That always means it adds a value to the end.
Yes, add. So this dot infinite set dot add num.
What's the difference between add and push?
Add is just a method that you would use with sets, and since we went with the built-in set method here, I'll just use
Got it.
the add. If we
Thank
just if we just did initialized it as an array, um, then we would use push. I guess that's just tradition. But I want to use an array because an array would be able to, you'd be able to add more than one of the same number. Whereas with a set, if the number already exists, you're not going to be able to add it to the set. What's up, Kev? What you thinking?
The problem is the minimum.
The minimum?
Yeah, I'm looking through the documentation on set, and there doesn't appear to be a method that'll give us that.
What do you mean? Oh, pop smallest, you're saying?
Yeah, unless somebody knows some magic, we'll have to step through it.
Mm,
We're not forced to use a set object. Could an array object do us a better job?
it could, but it's not technically a set, right?
Well, but does it need to be a set? Does the problem say we have to use a set?
No. I mean, if we have,
Maybe it doesn't matter. I don't know.
yeah, let me see. No, I don't.
It's at most a 0 to 1,000. That's not that big of, and it's not nested or anything. So maybe that's okay.
Yeah. This will actually return. This one actually returns. Remove and return the smallest integer contained in the infinite set. So I'm just thinking because if I wonder if there's a way to.
Oh, we need the. There's a delete method.
If we initialize the set to 1,000 when we go in while I is greater than 1, then it'll be in reverse. So we know the last number is always going to be the smallest, right? If we keep it sorted.
If we always push to the end, yeah, that seems valid.
Let's see. And then if
But that means that when we do our pop smallest, we actually have to remove that item from the set.
yes, remove it, so we would pop it.
And there's a delete method.
An array
The
would definitely be
documentation I'm looking
easier.
at doesn't look very clear.
What are you looking at? Just JavaScript
The
set.
MDN,
Gotcha. Let me see.
I think we can just say set.delete value.
And that'll return the value that was deleted to.
Um,
Nah, it returns a Boolean.
no, you'd have to grab it first and then delete it.
Actually, let me think of something really quickly because Never mind, that would just be too hard. Yeah, so we don't have to do this either. We could stick just to keep things simple for now. I mean, if we really wanted to, we can find the smallest and delete it. The thing is, we have to find the smallest before we could delete it anyways.
Right.
So I mean, just to do it like brute force and get something here, we could say there's at most going to be 1,000 in here.
That empties the whole array out, though, wouldn't it? Or the whole set out?
Let's see. Option. I'm tired. Does it? No, because it'll start at 1, so it's
You have
looking
to
for 1.
you have to break, though, don't you?
No, you would just return, because this would return you out of this whole thing. So it's starting at 1. If 1 exists,
Oh, that's
then
messed up, dude.
what?
What happens to that loop will never get garbage collected then?
What do you mean?
Screw it. If it'll run, it'll run. This looks so ugly to my C# eyes, man.
Yeah, and then if there's only 1 integer left in the set and it's 1,000, then you're going to do it 1,000 times, but 1,000 is not really that much at the end of the day either. Does anyone else have any input on this?
Well, now the fun part, we have to write the loop that steps through the commands.
What do you mean?
We have to build something that looks at these words and calls the proper function with the proper parameter.
I think the problem does that, doesn't it?
Oh, really?
Object will be instantiated and called as such. So your object is going to be, yeah, then object dot hop smallest ram1 object dot. Yeah, I think they do the calls. I think they do all these calls. I think it was just used for.
Okay, well,
Dang,
if that's an acceptable JavaScript class, let her roll.
let's try her out. Input, answer. Alright, I think that worked out. Aha. Output expected. Okay. So, what are we doing wrong here?
I can't tell. I mean, those look identical as far as they go.
Hmm. Hmm. Our output.
And expected. I mean,
Yeah, even as far down as here, it looks like it's still lined up. Let's see.
oh,
Ah,
Ow.
you just have to put a greater than equals at your 1000.
okay.
This is a horrible, horrible problem.
No. Greater than or equal. Oh, wrong one.
So your loop only counted to 999.
No. Are you saying this one too?
The initialization.
Yeah, I did, and it's still not working. Huh. Well, I is less than or equal to 1000.
I think your pop smallest needs it too.
Hmm. Oh, nice. Whoop, whoop.
What a weird, weird problem.
I know. I haven't had one where you actually have to build a class yet. This was a first. Hey, we got it.
Now fireworks.
Yeah. How much time do we have left? 27 minutes? Move pieces to obtain a string. This is going to be fun. All right, let me just control B, add the third. Let's see, so we're going to be putting in a start string and a target string. Okay. Let's get these examples down. Hey, at least we get 3 examples in this one. The last one, we only got 1. Right. Cool. Let's see what this is all about. You're given 2 strings, start and target, both of length n. So they're going to be the same length. Each string consists only of the characters L, R, and underscore, where the characters L and R represent pieces, where piece L can move to the left only if there is a blank space directly to its left, and a piece R can move to the right only if there is a blank space directly to its right. The character underscore represents a blank space that can be occupied by any of the L or R pieces. Return true if it is possible to obtain the string target by moving the pieces of the string start any number of times, otherwise return false.
Yeah, that's not too bad.
Okay. So
You make basically a do while, and you step through. You'll have a start, but I would say store that in something called current, because you're just looping through a current until it equals the target or doesn't. And you just step through whatever you've got, and you say, if it's a letter, if it's an L and it has a space to the left, move it. If it's an R and has a space to the right, move it. Does it equal the target? No. Go through the loop again.
There's going to be cases where there's only an L or only an R, right?
Right. And you could filter those, do those first.
Okay.
I don't know. There's probably a slicker way to do this.
Yeah, I'm thinking, do we have to move anything?
That's the whole idea. Yeah.
Because if we count, like let's say for the first one, for example, let's say we go through this string and we see that there's one L, right? And then we also count that there's two R's. Then we know that if there's one L, that the first index of the string has to be that L. And we also know if there's two R's, the last and the second to last index of the string have to be R's. If these last two aren't R's, like let's say this R is right here, but there's an R in the middle, it's false. Right? So couldn't we just go through this, counting each character? If it's an L, increase our L count by 1. If it's an R, increase our R count by 1. And then just if the L count, let's just say the L count is 3, then we want S0, S1, and S2 to be L. If those if our L count is 3 and all 3 of our first 3 characters are not L, it's false. And if our R count is 2 and the last 2 characters of this target string are not R, then it's also false. But if the first 3 characters are L and the last 2 characters are R, we know that it's true. Without moving anything around. Or we could actually move them around, which is kind of like sorting, and then compare them at the end, right? I think that's where you were
Right.
going.
But how to say this? If there's any right to the left of a left, then the left can't move all the way to the left.
If there's any
Like the second
right,
example, the R can't move past the L to the right, and the L can't move past the R to the left, so that one can't ever happen.
so you're saying, okay.
I think you're a little too focused on the first example.
Yeah, I am. So, all right.
What's wrong with just doing the algorithm like they say and moving the letters?
So, hold on. So the characters, so you want to loop through the strings and then
Yeah. And it's a simple rule. If it's an L and it has a space to the left, move it to the left.
move it to
If
the
it's an
left,
R and has a space to the right, move it to the right.
move
That's
it to the
2
right.
simple rules.
So we're
Just turn the
looping.
crank over and over.
So we're looping through the string a bunch of times, basically.
Well, if you keep your the result of your last and then you run the algorithm again and it doesn't change, then it can't happen. You either equal the target or you equal your last go through. Those are the only 2 ways out of your loop.
So while current is not equal to last, iterate through the string and move the L's and the
Yep.
R's as most as we
Yep.
can. Most, yeah. Okay, gotcha. Okay. Yeah, you're right, because the R can, okay, yeah.
And then inside the loop, we'll check for equal in the target.
Well, now let's just say that hold on, I still kind of don't get it because the R is not going to be able to move past the L in this one, right?
Right.
But what if
So we'll get something like RL space, and then we'll get it twice.
what if
In fact, we get it forever. And the
so
first time we get it twice, we say, can't happen.
so what if the L was in the R spot and the R was in the L spot? Would we be able to reach this target? No, right?
No, I don't see how you can reach that target at all.
But let's say hypothetically you swap these two spots and instead the algorithm looked
But
like this.
then it would work, yeah. In fact, that's probably why they chose that example.
But the L can only move left, right?
Yes, and only into an empty space.
So how would you get to here? You wouldn't because
You can't. That's the whole point. That's the false answer. You can't get to there.
Okay. I think I get it.
Well, I think you better bang some code if you want to beat the deadline.
All right, let's try to so there's a
I don't
couple
think it'll be. It isn't that hairy. I don't think.
not equal to last.
And we before the while we say last equals start, and last equals start and current equals start. So they're the same going in.
No, because then it would never run this, right?
Oh, okay. Then last equals empty string and current equals start. That'll work. And we got to be real sure to say last equals current before the end of the loop.
There we go. All right. So we also need an I,
Now we
right?
do now we do a stupid character by character step through the array or through the string.
Oh, so a for loop inside of here.
Yep.
Should we use current just to make things easier?
Yes, we're only going to modify the current.
Okay, so if current I equals
L. Well, I think it works no matter which one you try first, but we'll find out.
but we also need to check the spot to the left, right? And current I minus 1 equals this. Then we'll swap spots, right? Let me just create a temp as an
But
empty string. Make this easier.
if I is 0 and you do I minus 1, you're going to break.
I don't think it'll break. I think it'll just return undefined, which would skip this, which wouldn't run it, at least in JavaScript. Yeah, this would be undefined and it wouldn't execute this code because we know that the left is furthermost left.
Now doing the swap is the tricky part.
Yeah, so we we temporarily, temp would be this, current I minus 1 would equal left, and then current I would equal score, right? All right, and then if current,
I don't know why you have to do temp equals underscore.
because if I replace, oh yeah, since it's static, right?
Oh wait, it's a string.
Yes.
Can we do that with a string?
Do what?
Change the letters, swap the letters,
Certainly, yeah.
and then we can't change string.
Because a string is really just an array of letters.
Yeah, that's a really good question. I know strings are technically immutable in JavaScript, so I don't know. I've never tried to do this before. Let's test it out.
Well, at worst, you work with it as an array. All you're really returning is a true or false.
Let's go ahead and
Now we
console.log
check. Well,
current right here. I just want to see what we get here.
okay.
This is the third one actually, right? Yeah, so it's not actually.
Well, that's a bummer.
Yeah, no, that makes sense. So
Could you? Is there like a replace where you could replace underscore L with L underscore?
I do remember there's a replace. That worked.
There is a string replace.
Yeah.
Immutable my behind.
It's misleading.
If pattern is a string, only the first occurrence will be replaced. Yeah. You try that. Current dot replace underscore L. Wait.
yeah, I don't know how you target the specific underscore L that we're looking for.
I
Their
like the
only
idea
example is a
earlier.
regex. I think I can make it work.
It would be good to just break it up into an array, right? And then just join it afterwards.
Yeah, that's a good idea.
That'd be too much.
L replace regex. Current. This is messed up. Current equals Wait, if you're doing string replace, why do you have to? Weird.
What if we did something like this?
Well, let's just see if this runs real quick.
You want me to run it here?
Well, let me finish typing.
Oh shit!
Oh,
Nope. I think I jumped the gun on that one. Oh, you want me to test it now? Nope.
I'm not happy with this replace documentation.
I'm gonna try to write something out quick since we only have a couple of minutes. That
Oh, and this is the same exact fucking thing. Thanks, Google. This replaced by that. Oh, I'm doing this all wrong. We want to replace underscore L with L underscore. We want to replace R underscore with underscore R. That might work.
just tell me when you want me to test it out.
Well, first you have to rim out all the stuff you've been writing.
Huh?
First you have to rim out all this stuff you're writing.
I'll just comment it out.
Yeah, let's see what this does.
It moves it.
nice.
If you do a check for I-1 and I+1 in the same if statement, I think that would remove the undefined.
You got that, Kev? I think he's reading something.
Um,
I feel like you almost got it though.
Whoever said that needs to jump in and do it.
You got this.
Okay, that might work. The apparently the replace is working.
Let me test it. Okay, so yeah, it is working. It's not pushing the last R to the right though on the bottom. Huh, what are we printing out here?
Current.
Current. Oh, so this is current and this is current, none of them are target. Okay. Yeah. I want to see what's printing out on mine.
Current I+1. Wait, what?
Ah, okay. See what you're doing.
It's able to put the rightmost R all the way to the right, but it can't do that inner R to the right for some reason.
Yeah, I see that.
I don't get having 3 things in the if statement.
Um,
I
yeah,
did that for the to try and prevent the undefined, but it doesn't seem to be preventing it, so I can remove it.
yeah. I like the split idea, taking the start and just splitting it into an array of characters. I think that might have been a little easier than using regex. I just don't know regex honestly, so
Well, we can try doing it as array. I'm not emotionally attached to our current solution.
it's 12 right now. So the Contest is over. But we did good. I wonder how everyone else did. I'm interested. I want to see the other solutions.
I think we could have whipped this one with 10 more minutes.
Definitely. Definitely we could have. Let's see, still got John is still muted over here. We'll give everyone a couple of minutes just to come back. I guess you try to whip it out if you want. Let's say current equals start split. Right? Is it cool if I just delete this stuff here?
Sure.
Or maybe at least just cut it out, put it down here just for reference. Alright, so let's comment this out real quick and see, because we do have,
The contest finished, right?
yes.
Okay. Apparently I'm not very fast at this.
Split. Yeah, who was, oh, okay. Yeah, we were working on the third solution over here right now. We have
Oh yeah, I
three
was working
three
on that
different
too.
methods of solving it. We had we were looking at splitting the string into an array of characters. We had a regex solution, and then I was just
God, a red.
exploring. Yeah.
Let me see that.
But we didn't really finish any of them. We're just exploring different options. But we can start on the first one. Who has a solution to the first one?
Did I? How can you see if you even like got it right? It like highlights it green, right?
If you can look at my screen really quickly. So if you go to, oops. Oh man, they already, okay, let's see. This is the one that just happened, right? So down in the problem, you submitted it, right?
Yeah, I submitted it.
So when you click submit, it says accepted.
Oh.
Yeah.
I think I got it then.
Okay.
Yeah. I'm curious what you guys got for this solution.
Yeah, it runs a bunch of different test cases. And sometimes it'll throw weird corner cases at your code and mess you up.
Right.
Yeah, so basically the first thing we did here, we were going to loop through the array, just multiple times, decreasing 2 cups at a time as many times as we can, and then start decreasing 1 once we didn't have any left in the other 2. But we're like, there's got to be a better way. So what we did was we sorted the array when it first came in, and then we popped off the max. And then we did if max is greater than amount 0 and amount 2, then just return max. Because we knew right here, since max is 4 right here, and 1 plus 2 is 3, it's less than max, we knew what we were going to be returning max no matter what. And then for this one, that it also had that case, so we saw that our max was 5, and since the other 2 options added together weren't greater than max, we were always able, if the other 2 elements aren't greater than max, we could always just return the max, and that's going to be the minimum amount. But if the other 2 are greater than max, then we created a total variable. We did max plus amount 1 and amount 2. So we added all of them up together. So for this one, it would be 9, 13. And then we did 13 divided by 2. and then we wrapped it in a math ceiling because let's just say the total was 12, then we were able to just do 12 divided by 2 and we get 6. But since it was 13, we were able to do 13 divided by 2, which gave us 6.5 and rounded up to 7. And then we just returned the total.
Interesting.
How did you do it?
I tried to do something similar to that where um like think about it, like you take the like you sort it and then you take the two lowest and sort of subtract off as much as you can from these two, like pairing them up, and then taking what's left and pairing it up with the last one. But that didn't seem to give me the right answer, so I literally ended up just doing a brute force thing where I just subtracted off like pairs from the two that had the most left until there were no cups left.
Okay, yeah,
And
that's what we
that
were
seemed to
gonna
give
do.
me the right answer. Yeah.
Yeah, we were gonna do that the
I'm
first time.
yeah, I'm thinking about like your specific answer. I'm trying to think if there's like counterexamples to that. Because I'm wondering how to justify the division by 2 there.
2 cups at a time. That's
Right,
all I
right,
got.
right, right. I'm thinking like maybe if one of them was like there was like one of them was like 15, another was 10, another was 5.
So if the other two, if one was 15, one was 10, and one was 5,
Yeah,
then
something where they're separated out by a lot.
yeah. So in that case, then the total would be you'd have 30, right?
Yeah, the total would be 30. So you would get 15 as the answer from LeetCode.
15,
Trying to
yeah.
think if that's actually like
And that's like borderline where we would have just returned the max because if it was 15 was one of them, 10 was one of them, and 4 was the other one, as long
Right. And then,
as
yeah.
as long
And you
as
don't do the math, you
max
just say, sorry.
yeah, as long as
I
max
suppose.
was greater than the sum of the other two, we just returned max.
You can believe that LeetCode threw some weird cases at it.
Oh, okay.
You can trust them to do that.
Yeah, honestly, I don't know exactly how to explain this, but I knew this. I was like, look, if we have a max and the other two numbers are not greater than the max, we're always going to be returning the max. Since the max was 4, but the other two numbers added up were 3, we're returning the max. Same thing here. The max is 5, the other ones are 0, we're returning the max.
Yeah, that
This
I
was
can
the one
definitely
where
see for sure.
we were like,
that one threw me off too.
yeah.
That one threw me off as well.
Yeah, it was an interesting one. Honestly, when we solved it, I was like, I don't know exactly how this works, and I was kind of just
Right.
curious
I
about
couldn't
a
Yeah,
math.
same
explain
here.
it.
Like I'm honestly not even convinced that the way that I ended up doing the brute force is like optimal either.
So you
Though
just
maybe that's just the mathematician in me getting very very pedantic. Because I took a lot of like math classes. We had to prove everything like without any ambiguity, and that part of me is like ruining his head there.
yeah. I wish
But
you could explain it to us better,
oh
honestly.
yeah, exactly. I was actually really surprised that my first approach didn't work. Maybe it just had like a small bug in there.
Yeah, yeah.
But in any case,
It's always something so simple. It's always like a small little tweak. I've realized.
oh yeah, of course it is.
That's the hardest one to find, though. If it was something big, it would be
Mhm,
obvious, but it's always that small little
mhm.
thing that's just so hard to find.
Oh yeah, I once had a project I was working on that probably like thousands of lines of code. I redid a bunch of the math subsystem and then broke literally everything and narrowed down the problem to a single minus sign that I forgot to put down.
Wow.
It was so dumb.
Wow.
Yeah.
That's great. Oh man. Hey John, did you solve the first one?
No, as a matter of fact, I just like I chimed in. I was getting all settled in because I did it on my own. But the first one, I see what I did wrong. I wasn't doing the ceiling, so like I kept throwing my numbers off. I'd like try and add the one that I'd like do a floor division on. In Python, you do a floor division, and that was screwing me up. And I was like, well, shoot, I just need to add one, and that wasn't always the case. I don't think so. The ceiling is what I should have done.
Gotcha,
Because there was
gotcha.
one test case that kept saying like you're off by one, and I'm like, right, but if I add one, then it messes up my other test cases that don't need the ceiling function is what I needed. Man, I'm over
Yeah.
here myself because I got I was like, all right, man, this is so silly, man. I got the next medium one. Did that for like 2 minutes, man. I'm like, oh, this one's easy.
Yeah, yeah.
But I like the way you described that one. That one's good, man. That's good.
Yeah, I like this solution. Yeah,
The one
the
thing,
just scanning through the array. We talked about that one initially, and I think that would have worked too. I think that's what you did, right?
Well, yeah. I didn't like it though, because
yeah,
there's
Yeah,
100% a way to do it a lot
we didn't
faster.
like
Oh
it so
yeah.
much
That
we didn't even try it.
oh
Yeah.
no, it's so icky. That's like big O of the maximum. Actually, yeah, that's like big O of like the max element in there, which I suppose they did say was less than 100,
Yeah.
so that's not too bad. But
That was kind of our justification for like, should we try this? Because we know that we only have 3 elements, and at max they're
mhm,
gonna be 100 each, which is like not
yeah,
really a lot at the end of the day.
mhm,
We knew that our maximum was gonna be such a small number of computations too.
right.
If we didn't if that 100 was a million, and instead of just cold, medium, and hot, we had like 1,000, that's a different story, or more. That's a whole
Mhm.
nother story. All right, who solved the second one?
I believe I did the second one as well. Oh yeah, I did that one. That one I was a lot more confident on. It just took me forever because kept running into issues with the language I was using. Um,
Cool. Does someone
yeah,
want to share their
yeah.
screen? Do you want to share your screen and share it?
Um, yeah, sure.
Cool.
Let's see.
Cool.
Then was the smallest number in an infinite set.
Yeah.
Oh, it didn't. Oh no, that's in C. Where's the? Yes. So I did it in Rust, but
Is
it
there
should
any way you
be
can make that just a little bit bigger?
you should be able to.
Cool. Yep.
Yep. Better.
Yeah.
Perfect. So the way I structured it was that the struct contained a um, basically the way that I conceived it was like you had the numbers from one to infinity, but like as you popped it off, it would like keep track of what the maximum number that got popped off was from that infinite set,
Yeah.
and increment that accordingly. And then once you've done that, if you try to put anything back in, if it's less than the maximum that got popped off, it would get thrown into like a separate collection. So there's like the infinite portion and then the finite portion.
Ah.
I wanted to use like a priority
Well,
queue for this, but
the thing is,
the API
yeah,
for it was really was giving me a headache, and so I was like, you know what? I don't care anymore. I'm just gonna use
that infinite thing
whatever.
threw me for a while, but if you look down at the constraints, it's really only 1 to 1,000.
Oh,
yeah, that took me
no
like
Yeah.
worries.
all of 3 minutes.
Yeah, my hair
Uh,
was standing up at infinite. I was like,
Yeah.
how can we put that in a
I
computer's memory?
Yeah.
I could
It
I
confused
couldn't
us at
do that
first.
though. That'd be it would uh, it would it would kill my competition heart. Um, and so like I had to do it this way. But I wanted to use a priority queue because that would do the sorting automatically. It would be a lot faster.
Mm.
Um, but but like apparently I don't know the API as well as I should have, and there are some features that are only implemented in the nightly version for some reason. So I was like, you know what? I don't even care. I'm just gonna have just an array list, and then I'll just sort it every time. Every time I add something to it, I don't even care anymore.
I was gonna say that too.
Yeah. So yeah. You can see the initialization. It
Yeah.
sets it to 1 and then empty. Oops. And then to an empty list. And then when you pop it off, you first check the finite list to see if there's anything in it and take it out of there first. But if there is nothing in there, then what it will do is oh, I think this is actually a logic error now that I think about it. Because oh no, it's popping smallest, right? So it tries to pop it off the list because that's like smaller than the infinite portion. And if it can't, then it will just like add 1 to that max number and then return it, basically. And then when you add back, it will check to see if it's less than the infinite portion. Because if it's bigger than the infinite portion, it doesn't have to do anything because all those numbers are already in the set. But if it isn't in the infinite portion, it basically just pushes it back into the list.
Gotcha. And the manual is the finite one, right? Okay.
Yeah, the finite one. I wish I had a better name for it, but I couldn't come up with anything on the fly.
No, I was just trying to see. Okay, and then the self is just basically what the equivalent of this in JavaScript, right?
Yeah.
Gotcha.
Yeah, it's the equivalent of this in JavaScript, this in Java, and also self in Python.
Yeah. Yep. Cool. Awesome. Nice.
Yep. Mm-hmm.
John, did you get this one?
Yeah, but I already closed it down and turned it off. I'm just chilling watching real stuff now.
It's all good. Yeah, I'll share our solution to this one too.
Python, I implemented a little set and then just basically made a little return function that I just made it to where it was simple. I like what he did though.
Oh, thank you.
Yeah. Just helping with the speed of it.
Mm-hmm.
Utilize a little bit more memory, but you get so much more response out of it.
Mm-hmm. Ironically, I felt like that one was easier for me than the easy one, like the very first one.
Yeah, I agree.
Yeah.
Oh yeah, definitely.
Yeah. Agreed.
I
think they only classified it as medium because it had like multiple pieces to it. And you really need class knowledge.
Yeah,
and
you needed to understand method thinking.
Yeah.
Thinking exactly. Yeah.
I'm sharing my screen right now if you want to check out our solution.
Did you guys actually use the fact that it wouldn't be bigger than 1,000?
Yeah.
Oh yeah, it changed everything.
Oh my goodness.
So if you check this out inside of our smallest infinite set, the initialization of the object, we just create this dot infinite set. So we're creating a set, and this is going to ensure that you can never put more than one unique value inside of the set too, just by default. And then we just loop through from 1 to 1,000, and we add each one of the numbers to the set. So upon initialization, we just loop through and add them one by one. Then for the pop smallest, we are this is super inefficient. There's probably a better way we could have done it too. But
oh yeah. I mean, I was
JavaScript doesn't have a method that gives you the smallest item in the set.
Oh yeah, I was running into that too. There are data structures that will let you do all of this like a lot more efficiently.
Definitely.
A binary heap is in particular. It's basically just like a sorted tree. So like there's a way to take out the smallest, but you can also kind of like index into it at any point. Literally just a priority queue.
What are you doing? Like a min heap in that case, right?
Yeah, just.
Oh, I'm sorry.
A what?
It was breaking up, but like a min heap, right? That way we can always pop
min heap.
And then
what
maintain the structure, right? Is that what you're saying?
What would be the benefits of using a heap over like a singly linked list? Because if you're doing a
Um,
lot of insertion with the singly linked list, that would be better than an array because you're not
oh,
reordering the entire list every time you insert something, right?
well, with a heap, you can, it it provides a way to take things out, take the minimum value out in like login time, and put in a new value in login time. So it kind of the way that I like to think about it is that it's like a data structure sort of in the middle of like a sorting algorithm in a way. Like it it's really nice to get data in a certain order.
Gotcha.
Yeah, but you don't have to do any like searching or sorting or anything like that.
Gotcha. Okay.
Mhm.
Yeah, and then so then if we started from 1 and we just incremented until we found it, which is still 1,000 operations. At worst
Mhm.
case scenario is not that many for a CPU. And if we did find whatever was the smallest value, we found it, we deleted it, and we returned it. And then for the add back, we just did if the infinite set has, but we put the bang operator right there. So if it doesn't have it, we just added it. And I believe the add is like a push, right? It adds it to the end cap.
Well, it's an append. It
Yeah,
pushes on
yeah,
the
it's Flash.
on the big end.
Yep.
Mhm.
Cool. Yeah, so that's that. And then did anyone get the third one?
I was working on it. I had an idea for
Same.
it, and then I tried it, and then I was like, "Oh wait, this doesn't actually work."
What were you gonna do?
Um, so like the way I was thinking about it is, it's kind of like almost like a chessboard, but like there's not very many moves that you can do. So it's gonna like take the
Yeah.
string and have it go through and try to do as many moves as possible, to get it reduced down as far as possible, and do that to both strings. And then if the end result is equal, then they should both then you should be able to get from one to another. But it doesn't work. It doesn't work at all.
What do you
So
mean to both strings?
Yeah, you only
so
manipulate one.
yeah. That was my error there. I was
Okay.
thinking too fast. Yeah. Um,
Gotcha.
yeah. And if I were to keep going with it, I'd probably think about that approach a little bit more. See if there is some sort of way to do like progressive sort of modifications to it until you reach the end result. But it would have to be a little more complicated.
Gotcha.
Oh, you know what would probably work that we didn't try
What?
is scanning from left to right for the L's and then scanning from right to left for the R's.
Oh,
Huh.
I like that idea. Uh,
Um,
Because we had a good swap thing. It's just we weren't able to swap every time it was possible.
oh, I
It
mean,
was showing us a clear example where it could swap an R and it wouldn't for some reason.
why would we scan from left to right and
oh,
then
wait,
from right to left?
here's an idea. You could, first of all, you need to make sure that the sequence of L's and R's without the blanks is equal. But then, like, think about like how many underscores are between each letter, and there's probably constraints on like what those have to be. So in the first, so like if you have like the number of underscores is gonna have to be like greater than or less than the number of underscores between the same two letters in the other one. I don't.
Can you
But
say that one
some
more time? I didn't
yeah.
really.
Sorry, I I'm coming up with this on the fly. So, um, basically, so first of all, so if you just got rid of all of the underscores, the two strings do at least have to be the same if you remove the underscores.
Mm-hmm.
Now think of that, but instead of like just removing the underscores, like so to count how many underscores are in between each letter in both strings. Um, there's probably now assuming that the two strings have the same sequence of L's and R's, you could sort of identify together the count of underscores between them, and there's probably some sort of set of constraints that you could put on how many underscores are between each letter that have to be satisfied. So like if you have like one string, or like so if like the first string is like R with like 5 underscores and another R, and the other one is R with 3 underscores and another R, you can translate the first one into the second one because you can move the R over. But if you start with one where it's R and then 2 underscores then R, it doesn't work. So in essence, like the number of underscores between two R's has to be bigger in the first string and less and smaller in the second one.
Kev, why did you say that you scan from left to right and then right to left for the R's, though?
I don't know. It's just something that popped into my head.
I'm wondering if you could do something like, because
It's just that I saw it having trouble with rights and I didn't see it having trouble with lefts, and we scanned from the left every time, and just my brain just said, hey, try scanning right to left.
yeah, they have to be in the same order, right? Like that's one thing. Like if it's
Yes, and L and R can't swap places.
yeah, so
Mm-hmm.
so they have to be in the same. So I wonder if there's a way to scan the start string until you reach a character that's not an underscore, and store that in like current start character, and then scan the target until you reach a character that's not an underscore, and if they don't match, you return false, right? Does that make sense?
Well, sort of, but always working is a different thing.
That's what I'm saying. That wouldn't work there. So then once you see that they do match, like if the first character that you hit in the start string is the third index, and the first character that you hit in the target string is the first index, and they both match and they're both L's, you know that you're good to move to the next one. So you're able to, if you just use a pointer for each string and move through each string until you reach a character that's not an underscore, you can determine whether it's a valid, whether the start and the target are going to be able to um, be equal based on the current indexes of each, or the current value of each one of the pointers, right? And then that way you're literally just scanning each string. Am I making sense?
Yeah, I can kind of see that. I mean, I don't know if LeetCode would accept it, but
I know.
I'd
Exactly.
be willing to try.
Exactly. The other part of that is like if you have 3 L's on the left and 3 R's on the right, that's easy, right? But if you have like LR, 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 that's where it could get a little challenging. I wonder if, let me just pop in here real quick. I know I probably shouldn't be doing this, but we have move pieces to obtain a string. That was the one, right?
Yeah.
I just realized something.
Yeah.
If you compare the index of the first L that you find and the first R that you find, and if the index is greater for that L, that first L, than the R, then for sure you'll know it's false.
Yeah.
Mm-hmm.
That's one way to like kind of cull the possibilities.
Yeah. Yeah. Yeah, that makes sense. There's a few different use cases, or there's a few different situations where you know it's going to be returning false, right? see. Just looking for a solution. I'll understand right away. Looks like oh, here we go. All right, I'm sharing it right here. So this is one of the solutions here. It's bigger than I thought it would be. Yeah, we have 3 for loops. So they're looping through.
Hmm. Oh, yeah, yeah, yeah. The first thing is checking to see if the sequence of Elsevier is the same.
Ah, I did.
Oh,
No, no, wait,
looky,
that's
they're
not quite. No, no,
scanning.
no,
They're
that's not quite,
scanning.
actually.
They're
That's not
scanning
quite.
left to right, and then they're scanning right to left.
They are, huh? Oh
Hmm.
yeah, look at that. Right possible push. Like, you know what, Kev? I was,
It take me a couple of minutes to piece this together in my head, but just looking at it, yeah, I
Mhm.
can see that working.
bro, if you put your head together with mine, man, look, I was actually
Yeah,
I was
yeah, I remember
starting
that.
something like that. Oh man, yeah. There was definitely multiple pieces to this
10
problem.
more minutes, we'd have had it.
I know.
Mhm.
Yeah, I wasn't thinking about incrementing these though. I was actually building arrays, so I don't know what I was doing there, but